Alright, chemistry class, we are looking at chapter 8 and I'm going to walk you through the chapter 8 review questions. You should be writing these in your notebook as so you can submit them, okay? Let's see here. It says list the 3 requirements for a correctly written chemical equation. So if you remember, basically the idea here is that you want to be able to write a word equation. So you need to be able to name the different compounds and use the words for the symbols. And then we want to write the correct formulas for each of the compounds involved. So that's the first thing after you understand the words and the names for everything. But you have to write the correct formulas. The formulas have to be the correct formulas before you balance them. Don't try to balance the equation or the reaction by changing the formulas. You write the correct formulas for everything involved, reactants and products, and then we are going to balance. Okay? And the balancing part is necessary because we want to conserve mass. You have to have the same number of atoms of each element on both sides. Okay? Number 2 here says give one example of a word equation, one example of a formula equation, and one example of a chemical equation. So basically here, the word equation, let's just use a simple one here. What if we said hydrogen gas reacts with oxygen gas to produce water. Okay? So what does that look like? Our formulas for hydrogen gas, if you remember, is diatomic. So it's H2, we put a G there. Our formula for oxygen is O2, it is also diatomic. We put a G there for gas. And it's going to produce water. Water is H2O. Okay? And that probably would be a liquid. Now, we want to balance that. So we want to balance this correctly. We presently have 2 hydrogens on both sides, but we have 2 oxygens on the left and 1 oxygen on the right. So we double this, and now that doubles the hydrogen as well, so we have to double this hydrogen. Now you've got 4 hydrogens on this side, 2 oxygens, you've got 4 hydrogens on the other side, that's 2 times 2 there, and you got 2 oxygens, so everything is balanced. Okay? Alright, let's write the formulas for each of the following compounds. It says potassium hydroxide. Potassium, you need to recognize this is a metal, and its symbol is K. Hydroxide, that's one of those polyatomic ions that I told you probably should definitely memorize and recognize. The symbol for hydroxide is OH. This is a metal and a polyatomic ion, these are all nonmetals, that polyatomic ion there. Potassium is in group 1, it's always going to form a +1 ion. Hydroxide, if you look at the table, is a -1. So when they come together, you just need 1 of each, and that's going to produce what? Potassium hydroxide, and that is the correct formula. Calcium is in group 2, so it's going to form a 2+, that is a metal, and nitrate is a polyatomic ion. So nitrate, you notice it ends in ATE, one of those polyatomic ions. The formula for that is NO3, and it is a -1 charge. And just look at the table. So this calcium here, you only need 1 of those, and you're going to need 2 of the nitrates. So you got to put this whole thing in parentheses, and then double that. Number 4, how many atoms of each type are represented in each of the following chemical formulas? Now it says how many atoms of each type. In other words, each element, how many atoms of each element. So if we look here, this N2, nitrogen is diatomic. It comes as 2 atoms in a molecule of nitrogen. That's how it exists in nature. But you'll notice that it's tripled. So what that means is you've got a molecule of nitrogen, you have another molecule of nitrogen, and you have a third molecule of nitrogen. How many total nitrogen atoms are there? 1, 2, 3, 4, 5, 6. 6 atoms of nitrogen. Okay? How many atoms of each type here in B? Well, you've got HNO3, HNO3, but there's 4 of them. So everything in this, there are 4 of those. HNO3, HNO3, HNO3. So how many hydrogens do we have? 1, 2, 3, 4. 4 hydrogens. How many nitrogens? 1, 2, 3, 4. 4 nitrogens. How many oxygens? 3 here, another 3, another 3, and another 3. That's 12. 12 oxygens. Okay? And I'll do this one quickly. Calcium hydroxide. You'll notice that you have a compound here, calcium hydroxide. Calcium hydroxide. But there are 2 of them. It's doubled. So you have 2 of those. And here we have how many total calciums? Well, we got 1, 2. 2 calciums. How many oxygens? Well, this OH is doubled inside of that compound. So there's 2 oxygens here and another 2 there for a total of 4 oxygens. There are 2 hydrogens here and another 2 there for a total of 4 hydrogens. Okay? All right, decomposition. To start a decomposition, you have to have some type of energy involved. So you have to have some maybe some heat energy or a spark or light or something like that in order to break something apart. I'm going to use this example again. Water. In order to break water apart into hydrogen gas and oxygen gas, somehow you need to have some energy initiated or introduced. So many times the water would be maybe you'd use electricity. Electricity could then separate oxygen and hydrogen into the 2 gases. Okay, so decomposition needs some type of energy, like an activation energy, in order to decompose and break it apart. Because you got to break these bonds. The hydrogen and oxygen have to be broken apart. A substance is decomposed by an electric current, like I just mentioned. What is the name of this type of reaction? Okay, decomposition. But if it's specifically with electric current, we might also call that electrolysis. Okay? Electrolysis. So you could separate water by electrolysis. In what environment do single displacement reactions commonly occur? Often in a solution. Okay, so you'd have a solid introduced and put into a solution. And in that solution you have some ionic compound that's dissolved. Okay? What is the basis for the ordering of the elements in the activity series? We didn't talk about activity series. We'll talk about that when we talk about electrochemistry. Okay? Number 9, write the chemical equation for the following word equations. Include symbols for the physical states. So we have solid zinc sulfide. So let's get the correct formula. You've got to write the correct formula for zinc sulfide. Zinc forms a +1. Sulfide forms a 2 negative. So I'm going to need 2 zincs for the 1 sulfide. Okay? That's the correct formula for zinc sulfide. And we're told this is solid. Oxygen gas. You have to know it's diatomic. It's a gas. Solid zinc oxide. So again, zinc, just like zinc sulfide, zinc oxide is going to be Zn2O. Oxygen is a -2 ion, zinc is a +1. Plus sulfur, sulfur dioxide. You see dioxide here? That's because these are 2 nonmetals. Dioxide tells me it's SO2. Okay? So this is a solid, and this is a gas. All right? Let's see if we can balance this. Might as well. Let's start with the zincs. We have 2 zincs on this side, 2 on that side. So we're good with the zincs. We have sulfur. 1 sulfur on this side, 1 sulfur on that side. Okay? And for oxygen, we have 2 on this side. We have 1, 2, 3 on that side. Well, that's kind of difficult. I'm going to show you a little trick. If you've got 2 on one side and you've got 3 on the other side, well, what I do, I can multiply this 2 by a number, 3 halves. If I multiply by 3 halves, 3 halves times 2 is going to give me 3. So I'm going to multiply this by 3 halves. Now usually we don't leave a fraction as a coefficient for some compound or molecule. So what you can do in order to balance everything with whole numbers is if you have a fraction here, we're going to multiply by that denominator. So I'm going to multiply everything by 2. Multiply by 2. If I multiply this by 2, that denominator is gone. I just have 3. Multiply this by 2 and multiply that by 2. That might be the more accepted balanced equation for this reaction. Okay? Aqueous hydrochloric acid. Hydrochloric acid is HCl. You don't need to know that. I'll just, you can look it up, or you can just look in the book, or I'll tell you. HCl, AQ is aqueous, plus aqueous barium hydroxide. Barium is Ba. Hydroxide is a polyatomic ion with a -1. So you get barium is a positive 2. So you're going to have 2 hydroxides to neutralize or to make a neutral compound for the barium with the barium. Yields, or it's going to produce what? Aqueous barium chloride. So barium chloride. Again, chlorine, the chloride ion is a -1. Barium is a +2. So I'm going to need 2 of these plus water. Let's make sure we put all of our states here: aqueous, aqueous, and liquid. Okay? Now, let's just balance it really quickly here. I'm going to show you another trick. It's nice to keep polyatomic ions together on both sides, and then you can just balance that whole group. You'll see we have hydroxide here, but it doesn't look like we have hydroxide on this side. Well, water actually is hydrogen and then the OH, and you can write it that way. So here's a hydroxide right there. So we have 2 hydroxides on the left, 1 on the right. So I'm going to have to double that water molecule there. Okay? That gives me how many hydrogens? That's going to give me 2, and this is everything's doubled here. So I have 2 hydrogens in here, but it's all doubled. So that's 4. So I'm going to have to double this so that I have 2 hydrogens, and these 2 give me the correct number. Oh no, that's hydroxides. Sorry. Oh, that's good then. That gives me the correct number of hydrogens. So these hydrogens here are 2, and that's 2 there. I have 2 chlorines right there, and I have 2 chlorines there, and I have 1 barium, and I have 1 barium, and looks like everything is balanced now. Okay? Alright, number 10 says translate each of the following. Now I'm going to say this in words, and you can write it down. So basically, I'm going to write it, it's going to be pretty extensive here, pretty elaborate. We have 2 moles, you're going to write this down, write these words down, 2 moles of zinc sulfide. I should actually say 2 moles of solid zinc sulfide reacts with 3 moles of oxygen gas to produce 2 moles of zinc or solid zinc oxide and 2 moles of sulfur dioxide gas. That's how you would read that right there. Okay? Let's read this one. Solid calcium hydride. This is a metal and a nonmetal. That's an ionic compound, calcium hydride. Reacts with liquid water, 2 moles of liquid water, to produce calcium hydroxide, I should say aqueous calcium hydroxide, and 2 moles of hydrogen gas. There you go. Please write those down. All right, let's balance these. Balance each of the following equations. Let's start with the, I guess it's not going to matter too much here. I think this is pretty straightforward. You got 2 hydrogens on the left, only 1 on the right. So we're going to double the HCl, and that actually gives us everything that we need. Now I have 2 hydrogens on both sides. I have 2 chlorides in both sides, or 2 chlorines on both sides. Okay, we have aluminum and iron oxide producing aluminum oxide and iron. So let's balance this. Let's start with the aluminum. See this iron all by itself? It's easy to put any number you need in front of that iron to balance the iron. So we might leave that until after the aluminum. I would do aluminum first. So I see that there's 1 aluminum on the left, 2 on the right. So I'm going to double this aluminum. And I've got 2 iron on the left. I'm going to have 2 iron here. And I have 3 oxygens on both sides. So that's it. That's all we have to do. Complete each of the following word equations for synthesis reactions. So synthesis means you can have 2 things, 2 or 3 things maybe, 2 or more things coming together. So sodium and oxygen. Sodium and oxygen. Oxygen is always O2 when it's by itself. It's going to produce what? Well, sodium oxide. Sodium oxide. What's the formula for sodium oxide? It's not NaO, because oxygen is a -2 ion, sodium is only a +1. So you're going to have 2 sodiums. And so you have to put a 2 in front of this. Oh, we have to put a 2 in front. Actually, before I do that, the oxygen, I have 2 on this side. I'm going to have this doubled, and that actually quadruples. Not quadruples, but I have 4 sodium now. So I'm going to have to make this a 4. Okay, so it's a bit of a trial and error sometimes. You check one thing, and then you realize when you put a number in front of a compound or molecule, it changes everything. So you have to double check what you did before. Magnesium and fluorine. So magnesium and fluorine. Diatomic. When these react, you're going to get magnesium, which forms a +2 ion, and fluorine, which is a -1, so you're going to need 2 of those. And it is balanced already. Okay? Complete and balance the equations for decomposition. Well, decomposition means they just break apart. So HgO, this is mercury oxide, and this means you're going to introduce heat. You're going to break it apart into the elements. Remember that oxygen is diatomic. So O2 means we had to have 2 of these compounds over here to get 2 oxygens on both sides. That just doubled the mercury as well, and so I'm going to double those. Okay? Water, we're going to break water apart into what? Into oxygen and hydrogen. Hydrogen and oxygen. And we've done this one before, so I'm going to have to put a 2 in front of this and a 2 in front of that to balance it. Alright, complete and balance the equation for single displacement. Single displacement, remember, is when an element, usually a metal, it could be a non-metal too, but a metal is going to replace the metal that's in the compound. If it's a non-metal all by itself, then it's going to replace the non-metal that's in the compound. So this zinc, assuming that it is more reactive than the lead, is going to kick out the lead, and it is going to be in the compound here with the nitrate. Now, just because this is NO3 and there are 2 of them with the lead, doesn't mean there's going to be 2 of them with the zinc. You have to know what the ion charge is. The zinc forms a +1. Nitrate is a -1. So you just need 1 of each. You don't need the 2 on the zinc nitrate. You don't need the 2 over here outside the nitrate. That's only for the lead, because this is a lead 2. This is lead 2 here. Okay? So you have to write the correct formula. Now what's going to be by itself? The lead gets kicked out and is all by itself. Now if I want to balance this, I have 2 nitrates, so I'm going to have 2 over here, and I'm going to have 2 zincs. Aluminum is going to kick out that nickel, and now the nickel is going to be by itself, and the aluminum is going to be in the compound with the sulfate. Now, aluminum forms a +3. Sulfate is a 2-. So the 2 is going to go for the aluminum, and the 3, you're going to have 3 sulfates to form that correct formula. Let's balance it. I have 2 aluminum on the product side, so I'm going to have to double that aluminum. I have 1 nitrate on both sides, and, oops, nope, I'm going to have to triple, because I have 3 sulfates, I'm going to have to triple this compound. You can't put parentheses around the sulfate and put a 3 subscript. That would change this formula. That's not the correct formula for nickel sulfate. You have to put a 3 in front. That changes also the number of nickel, and so you have to triple that. Okay? Alright, now we get a double displacement. Double displacement means you're going to have the metals switch places. So the silver was with the nitrate, now it's going to be with the chloride. And silver is a +1, chloride is a -1, so just one of each. The sodium goes with the nitrate. Sodium is a +1, nitrate is a -1, so you just need one of each of those, and you're balanced. Okay? Here, we're going to have a double displacement. Switch places, just the metals. So the potassium is going to go with the nitrate. Potassium is a +1 ion. Nitrate is a -1, so just one of each. Magnesium is a +2. Hydroxide is a -1. So you're going to need 2 hydroxides. Now we need to balance this. Since I have 2 hydroxides on the right, I'm going to have to double this whole compound there. That then also doubles the potassium there. So I have to double this where the potassium is. That doubles the nitrate, and I do have 2 nitrates on the other side, so we're good to go. Okay? All right. The ones here are all combustion, and these are all combustions of hydrocarbon. I told you you must know that a hydrocarbon, when you burn it, doesn't matter which one of these are, which one you have. These are all hydrocarbons. Hydrogen and carbon. They're all going to burn in the presence of oxygen and form what? Carbon dioxide and water. Every single one of these is carbon dioxide and water. Carbon dioxide and water. We just have to correctly balance them now. Okay? So let's start here with the carbon. I've got 1 carbon on both sides. I've got 4 hydrogens, so let's go ahead and double this one so I get 4 hydrogens. That's going to give me 2 and another 2 oxygens for a total of 4, so I double this. Okay? Let's balance the next one. I have 3 carbons on the left, so I'm going to have to triple that carbon dioxide there. That's going to give me, I need 6 hydrogens on both sides, so I'm going to triple this. Let's see what that does for the oxygen. See how I'm leaving the oxygens last, because oxygen is kind of by itself here, and I can easily put a number in front of it to balance the oxygens. So this gives me 3 times 2, that's 6 oxygens, and another 3 here, that's 9. That's kind of an odd, awkward number to be worked with, but that's 9. What do I multiply this by? There's already 2 in this molecule. What do I multiply 2 by to get 9? Well, I have to multiply by 9 halves. But if you don't want to leave a fraction as a coefficient, which seldom is not the case, now I'm going to multiply everything by 2 to get rid of that denominator. So 2, multiply this by 2, and that just leaves the 9. Multiply this by 2, and that's 6. Multiply this by 2, and that's 6. And that would be the correct balanced equation for using whole number coefficients. Okay? All right, 5 carbons. 5 carbons I need. 12 hydrogens, so I'm going to multiply this by 6 to get 12 hydrogens. Now, what's the deal with my oxygens? I've got 10, 5 times 2, and another 6, that's 16. I'm going to multiply this by 8. 8 times 2 gives me 16. Okay? Alright, let's see here. 17. Circle the element within each pair of elements that is more likely to replace the other in a compound based on your activity. Okay, we're not doing activity series, so we don't have to worry about number 17. Okay, we will talk about activity series later on when we look at electrochemistry. And therefore, we don't have to do number 18 as well. Okay? Alright, so I hope that's helpful. Balancing equations, working with writing equations, making sure that you have the same number on both sides, the number of atoms of each element, and understanding the types. You've got synthesis, decomposition, single displacement, double displacement, and combustion. All right, let me know if you have any questions, guys. Great job.